Okay, and we are live.
Hi.
Hi everyone. Thank you so much for joining us this VJUG session. Now with Marcus here as our guest speaker. Marcus is going to talk to us a little bit about the Craftsman's Guide to Design a Clean Architecture. So we're very excited to hear about that. So without further delay, I would like to introduce Marcus to you. So please, Marcus, introduce yourself to our audience.
Okay, well, my name is Marcus Biel. I'm a clean code evangelist. That just means that I'm really passionate about clean code. Yeah. Besides lots of other stuff, I also work as a clean code coach and a Java consultant. Yeah, I guess that's enough about myself. Okay.
Cool. So before we start, let's just say to you guys that we have.
Oh, there they are.
Oh, okay. Sorry. Hey, Dublin Jug, can you please mute yourself? Let me mute them. Okay, there you go. So before we start, please join us on virtualjug.com. You can go over there. There is a link to join a Slack channel. So we'll be happy to relay any of your questions directly to Marcus if you have them. Just go into our Slack. There is like a channel called Live Session. Join the channel and post any live question. I'll be happy to relay that. Also joining us live is the Dublin Jug. Hello, Barry. How are you?
No, they're muted.
Yeah, I'm trying to unmute them, but for some reason I'm not able to do them. Then, well, I hope that you can hear us, and I'm very happy to have the Dublin Jug with you guys. Oh, there you go. Can you hear us, Dublin Jug? Dublin Jug. Okay, Dublin Jug can hear us. Apparently, we cannot hear them.
Hey, Dublin! Nice to have you.
Yeah, nice to have you. I actually been into the Dublin Jug a couple of weeks ago, and they are a very friendly crowd. So if any of you guys have any chance to come up to their jug, we're very happy to have them there. I think we can hear the Dublin Jug. Hello.
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 Ooh.
Hey, nice to have you. So yeah, we have like a very nice crowd over there.
That looks
So
organized.
yeah, it looks organized. Hello, guys. So without any further delay, I'll hand in the word to Marcus so he can start his presentation.
Okay, let me share my screen. One sec. So while I share my screen, I'm sorry you will not see my video anymore. I tried to fix this today, but didn't make it. So, okay, here. Can you see my slides? Let me know.
Yep, we can see it.
Okay, so great. And I will start. So today I want to give you a guide of how you can design a clean architecture. And well, when we talk about an architecture, I think there are two fundamentally very different approaches available. On the one hand, we have this cool, new, fancy way of a microservices architecture. Oh, can you mute your microphone? Because
oh yeah, sorry,
I can hear myself twice. Okay, thanks. So on the one hand, we have this cool, new, fancy way of a microservices architecture. And on the other hand, we have this old, traditional, boring way of a monolithic architecture. Well, honestly, to me, I prefer to make a decision that is not based on these emotions, that is more like based on facts. And yes, it is a fact that microservices have lots of advantages. But these advantages come at a price. There is no free food, right? They come with lots of added amount of complexity. And you might say, well, complexity, that's not much, right? But to me personally, I mean, as a clean coder, I really have zero tolerance for complexity. So before I jump the microservices train, I will see if I can solve the problem just as well with a much simpler monolithic architecture. And that's what I want to show you today. Okay. So, oh, sorry. What's happening now? I'm so sorry. One sec. So, no. Now something is going really wrong. I'm at the end of my talk.
Oh, okay.
One sec. I have this fixed in a second. Okay, so okay, fixed. So, well, I already introduced myself, so I don't have to say much more. I might just as well, but say that if you, after the talk, want to talk to me, want to contact me, you can do so easily on Twitter. @MarcusBeal is my handle, and my direct messages are always open, right? So just send me a message and we can chat, okay? And if you want to know more, I also have a website, Clean Code Academy. Okay, so that's enough. So back to the talk. So to tell you what a clean architecture is all about, I think we first of all have to define what is actually a clean architecture to me. And to do so, we first of all have to talk about an architecture in general. And well, obviously, you would know what an architecture is about, so let's come straight to the point. Well, you see here my slides, and let's just assume we're all together in an office, standing together as a team, right? And you're explaining the architecture of your system to me. And usually, from my experience, that is done by looking at a whiteboard like this, and we see the architecture as boxes, and they're somehow connected, right? So, and that, to my experience, usually looks very, very clean, just like you see here, right? Everything is simple, easy to understand, happy, happy. Well, unfortunately, the reality is a bit different. It's not as clean and simple. Sorry, drinking. Usually, the reality is more like we have a system that we call a big ball of mud, right? So here we see every component is tightly connected to every other component in some way or the other. And that, to my experience, is what the average architecture really looks like. And that obviously is not a clean architecture. And that obviously is what we're trying to prevent when we're trying to achieve a clean architecture. So what's the reason here? Why is it so that we usually end up like this? And for this, I see two reasons. First of all, well, when we start designing our system, everything starts simple and clean, right? Because we start on the green field.
I'm sorry, Marcus. Well, it seems that your slides are stuck. They're not changing. So we're still at the title slide.
You where?
At the title slide. So the first slide.
Oh, maybe the sharing stopped?
Yeah.
One sec.
So we see your slides and your sidebar with the mini slides on the side.
You see them now?
Yeah, so we see like a slide with white boxes and arrows.
And when I change them, you see this also?
Okay, yeah. Now they seem they seem to be changing now.
And when I go on full screen, you don't see it, or you still see it?
I don't. So can you try to change the slide now?
Yeah.
No, actually, when you.
Okay, so I stay there.
Yeah, it seems when you go full screen, it doesn't change any slides.
Okay, so okay, so I stay here then.
Yeah, that one is fine.
Okay, perfect. Well, so where did I stop? Well, I said, we're trying to achieve a clean architecture, and usually, however, the clean architecture is not so clean. Usually, the architecture looks more like this, right? So there are two reasons for this. I think, first of all, that we start with a project simple and clean, right? But over time, more and more features get added because the business guys, they love features. And so more features are added, and then sooner or later, the architecture looks like this. Because the architecture, as we were intending it to be, was never technically enforced. So that is, I think, one problem that we have to get fixed. And I'll show you later in the next slides of how we can achieve that. And then, second, why is it that we usually end up in the big ball of mud? Also because I think it's just a way of a perspective, because from a high-level perspective, that might actually be true, right? That is how our architecture looks like. But it's not enough to just look at the high level, right? We have to take into account all the layers. And if we do that, well, then that is just the reality, right? And we have to like live with it. And that is a big ball of mud. And this is what a clean architecture tries to prevent. A clean architecture should really be like this. And this is what we are trying to achieve. And this is what in the talk, I will show you how we can achieve that. Okay, so how can we achieve that? You see here we have boxes and we have lines that connect these boxes, right? I think that is about modularity. We have to achieve a clean modular architecture. Modularity, or you can also call this concept divide and conquer, right? It is about we have a huge complex problem and we're not able to easily solve that. So we're splitting up this problem into smaller units. And each unit, again, is it now digestible? Is it now easy? If not, we further split this up, right? And this is what we have to get right. We have to get a proper, effective modular architecture. I think this is the key towards a clean architecture. To further illustrate this, I brought you here this image of this little boy. So the little boy is playing with Lego cubes. I think Lego is a great example, again, of modularity. Each Lego cube doesn't do much, but putting many Lego cubes together makes it super powerful. Even adults play with Lego, right? We love Lego. We can even build up statues a few meters high with Lego. And this concept made the Lego company a multi-billion-dollar company. So you see really how powerful this concept is. And yeah, this concept is not only restricted, obviously, to programming. This is just generally how we as the humans, how we solve problems. And obviously, this is also why we apply that principle in programming. Okay, let's go one step further. If we look at a programming language, Java in our case, also Java is modular to the core. Here we see a hierarchy, right? A system usually consists of methods, classes, packages, and now with Java 9, hooray, even of modules, right? And modules even has the name modules, modularity in it. So to further, to not confuse you, within the talk, I will later on speak a lot about components or units so that we don't confuse Java 9 modules with the other concept. And so you could also say, well, you could disagree and say, well, this is about layers. But layers is just a different word for the same idea, right? We're splitting up complexity into smaller units. So again, we have to get this right. We have to get our clean architecture from the ground up, and we have to get each layer perfectly clean. And even more, I think, when we look at this and when we realize this is a hierarchy, we should also realize, I mean, every module consists usually of packages, and every package of classes, and every class of methods, obviously. And this is why the smallest units, like here the method, are usually the most important units. These we have to get right first and foremost, right? Because the method is the one smallest unit that appears so often. And so it is not enough to just look at this high-level overview here, right? This is a problem if we just focus too much on this high level and we forget about all these small details. But this is also something that we have to get right to achieve a clean architecture. Okay, let's take a little break here. So within the talk, I will have to give you a lot of knowledge. I have to give you a foundation of how we can achieve a clean architecture. There will be some building blocks that I will tell you about. But now let's just take a really fast forward and let's just assume we know all this already. So now we want to achieve a clean architecture, a clean system. So how can we do this top down? So first of all, we have to decide for some approach, some architectural approach that we want to take to achieve, to design our system. And here, there are different ones available, obviously. One that I really like is the hexagonal architecture. It's also called ports and adapters. I don't know about you, if you know about hexagonal architecture or not. Well, if you do, great. That really helps to understand the rest of the talk. But it's also not required, right? You can, I put here a link that you can later on read if you're interested to know more about the hexagonal architecture in the bottom. You can also look at this later. So for now, there are just a few things that I want you to understand about the hexagonal architecture. Well, you see here again, this is a high-level overview, right? You see again, this is all nice and clean looking, right? We have two layers here, the infrastructure layer and the domain layer. So obviously we have to now technically enforce that these layers stay as clean as they are. That it's not possible that, for example, the infrastructure layer leaks into the domain layer. Because if that would happen, then this would be the end result, right? And this is what we're trying to prevent. So how can we get this done? And I think here the key is Java 9 modules. We can make each layer, the infrastructure layer and the domain layer, its own module. And this will technically enforce that this layer, that the system on this high level really stays as clean, and that it's not possible that the infrastructure leaks into the domain layer. Okay, and obviously this we can do with any kind of architecture, right? Because any kind of architecture is also a layered architecture. Why I have picked here specifically the hexagonal architecture is because it has some advantages. First, it keeps the infrastructure, these technical details like HTTPS, REST, SOAP, database, it keeps all this separate from the domain. This, I think, is another key towards achieving a clean architecture, because these things, they change for different reasons at different times, right? And, well, obviously, we're making our software for a business. And so the domain is actually the much more important thing. And it really helps understanding the whole concept if we keep these separated. And this here hexagonal architecture does really nicely. Okay, and this is also nice because it helps us with domain-driven design. Domain-driven design is, again, a huge topic. And I don't know if you know about domain-driven design. I hope you do. If you don't, in the meantime, there have been many, many books about domain-driven design been written. The first one was from Eric Evans. So I highly recommend you, if you haven't done so, to read the book Domain-Driven Design. This can really help us towards achieving a clean architecture. And I will, within the talk, again and again, talk a bit about domain-driven design, because I think this is, again, a key of how we can achieve a clean architecture. So you don't need to be an expert of domain-driven design. What I want you to know, I'll tell you within the talk. Okay, just one more thing here. You see this blue hexagon to the side. This is just an idea, because we can use the same concept if, like later on, we still have to scale up our system towards a microservices architecture. We can still do so. We can use the same approach that I will show you to scale up our system towards a clean architecture. Okay, so now I want to talk about how we can achieve the clean architecture actually. And I think there are some building blocks that we need to understand. We will have to talk back about modularity, right? How can we achieve a clean modular system? And the two most important building blocks here that I see are coupling and cohesion. Okay, let me talk about coupling first. Sorry. So, coupling. What is coupling? Well, coupling is about two or more components and about how closely these components are connected, are coupled to each other, right? So we usually, when we talk about coupling, we talk about a tightly coupled system and a loosely coupled system. So on the left side, I have symbolized a system that is tightly coupled. That would be the big ball of mud, right? You see, we have lots of connections. So tight coupling, one thing is about the many connections here. But that's not all. It's also about the strength of the coupling. I try to visualize that by making these lines really, really solid and strong. On the right side, however, we have really small dotted thin lines. To visualize, the strength here is really loose. Within the next slides later on, I will tell you much more about the strengths of the coupling. This is a big factor, an important factor. For now, just understand there is the strength of the coupling that factors in if we are speaking of a tightly coupled system or a loosely coupled system. The details I'll show you later. So now, why actually is coupling a problem? Or even sometimes I hear coupling in general is bad. Okay, maybe let's clarify this first. Well, if coupling was generally bad, well, just imagine we would have all the lines gone, right? So we wouldn't have one system anymore. We would have 6 distinct systems without any connection whatsoever. So we would not have one system anymore, but 6 distinct systems. So this doesn't help, right? We do need coupling. Coupling is helpful. It is just a question of the amount of coupling. It has to be balanced. We don't need too much of it, because coupling is like a drug. The right amount and it helps us. Too much of it and it can really, really poison us. It can really make a lot of problems. So now I want to see why. Like, what kind of problems does this make, possibly? Okay, so let's go to the next slide. So let's just assume we're changing one component, in this case, the yellow component, okay? So if we change the yellow component in both cases, in a tightly coupled system and in a loosely coupled system, obviously, because we changed that, there might be changes required in the rest of the system. So we have to check each component that is directly or indirectly coupled to the yellow component. In our tightly coupled system, well, the problem is every component is directly and even indirectly coupled to the yellow component and strongly coupled to it. And that means we have a really high chance that a single change here in the yellow component reflects to many, many changes to a rippling change through the entire system. In our tightly coupled system, this is so tightly coupled we don't even have distinct subcomponents anymore. So there is a high chance that we will have to change the entire system. And if you have ever worked in a tightly coupled system, and I'm sure you have, you know the pain that this can be, right? So this is why we try to avoid a tightly coupled system. Okay, let's now, on the other hand, look at the loosely coupled system. So here, in the case of a change to the yellow component, we have just one component that is indirectly coupled to the yellow component. We don't have any, that is directly coupled to the yellow component. We don't have any component that is indirectly coupled to it. So now, and it's really loose. So we have a big chance that even though we change the yellow component, there is no change whatsoever required in the orange component. And even if, the amount is probably much lower than in our tightly coupled system. Also, coupling is about knowledge. To understand how a certain component, let's take the yellow component again, to understand how it works, well, we also have to understand bits of the components that it uses, right? And we have to understand the more tighter this coupling is. So this again makes it really painful for us to abstract. We cannot abstract. We have to, in the tightly coupled system, we have to always understand the entire system. That makes it really painful to work here. And this is why we try to avoid that. Okay, I hope this is clear now. So now, before I talk about the strengths of the coupling, I want to make one point clear. So far, I was just simplifying. I was just speaking of a tight and a loosely coupled system. That it was not fully true, because coupling is not a binary attribute. Coupling is a sliding scale. For me, I visualize this here because I'm not a native English speaker, so I think this really helps to understand there is many levels in between, and this is one of the reasons why coupling is so hard to get it right. There's so many factors. So now when it comes to the factors, when it comes to the strengths of the coupling, let's look at this. And the strengths of the coupling, I really have spent a lot of time on that. There is, let's say, 1 million of factors that influence the strengths of the coupling. And obviously the time is not enough to talk about all these here. So I've just picked 3 factors that are important to understand when we talk about the coupling, to give you, first of all, an introduction, and also to make you think about like what coupling is all about, right? To just give you a feeling of coupling. Okay, so let's start with the distance of the components. So the distance of the components, right? We're back at our hierarchy. The question now is, where are the components that we're talking about, that we're looking at now? Are we speaking of very distinct large modules? Or are we, in the best case, speaking of very small methods within the same class? That really makes a difference because, well, the higher in the hierarchy we are, usually the more code is involved and also the more complexity is involved. And usually also the more developers are involved. And this is why things can get really risky, right? The chance that a single change will relate to many developers and will relate to a lot of work is much higher the higher we are on the hierarchy. And therefore, if we have to make a decision towards what kind of coupling we want to use for two components, well, the higher that we are in the hierarchy, the more we will strive for a loose form of coupling. And the more lower we are in our hierarchy, the more it might be acceptable that we have a more tighter form of coupling. I'm saying tighter because I'm not saying we want tight coupling. We never want that. But again, with everything in design, everything has two sides. So we always have to make an informed decision, as I'll show you in the next slides. And when we have to make the decision, the important thing is here we have to keep the hierarchy here in mind, because if we are just speaking about methods, then it might be acceptable that the coupling is a bit more tighter. Okay, let's look at this a bit more in detail. So one thing here is, for example, what kind of a coupling do we have? Do we have an asynchronous form of coupling or an synchronous form of coupling? Here I try to visualize an asynchronous way of coupling. We have the yellow component and we have the blue component. So the yellow component would be the sender and the blue component would be the receiver. And they would exchange messages through here. This could be a message queue, right? Message queues are, well, you would say probably simple, right? But still, a message queue is some added amount of complexity, right? And here the question is that we have to make, do we need that or not, right? Because we have to implement the message queue. We have to understand the message queue. We have to test it. We have to maintain it, right? And the message queue will cost us performance and resources. So here we really have to decide, do we need that? Well, this brings lots of advantages because it decouples the two components in time. Because if the sender sends a message and there is a problem, or the receiver received the message and there is a problem in receiving, both components are decoupled in time. Wow, great advantage. Lots of flexibility, cool. But we have to take into account the price that we have to pay. So we have to make an informed decision. Do we need that or not? If we're speaking of two modules, or remember I showed you initially the hexagonal architecture, and if we're speaking of even two microservices, right, then this asynchronous way of coupling is a great advantage, and the price is probably justified. But we would not use that, I'm sure, if we're speaking of two small, simple methods. And that is one of the few decisions that we have to make when we want to achieve a clean architecture. Okay, let me further illustrate this. Here, we see we have two components. And sometimes, if you're seeing this in the video, this might not perfectly come through. So let me tell you, these are two different blue colors, two shades of blue, not the same ones, very, very close. So I want to visualize with the colors, we have two components that are very close to each other from the functionality. And we could also assume they are very small. Now they both have the same kind of functionality. Here, this black dot, right? And this is duplicating code. So we're violating the principle of dry. That is a problem, right? We don't want to duplicate code. So let's fix that. So to fix that, we could share this functionality. But now we have replaced one problem and we have introduced a new problem. Now we have coupled the two components. So we have replaced one problem with the other, and that might be a new problem. And the question is, do we want that or not? In the case of two components that are very, very close and small, that is probably justified and everything is good. But let's assume we have 6 very distinct large components, 6 very distinct modules, for example. And it looks a bit different, I guess, because now we couple all these components together. In domain-driven design, we might say they are in different bounded contexts, right? And if they are, it might be not such a great idea that they all share the same functionality because now they are so tightly coupled together. In this case, it's probably a better idea to go what we call separate ways. So we would not share this functionality. We would on purpose duplicate the code. Because that's what a clean architecture is always about. It's always about trade-offs. We always have to make informed decisions. It's never easy. It's never black and white. These are the kinds of decisions that we have to make to achieve a clean architecture. Okay. Let me go on. So now, more about the strengths of the coupling. So another factor that is important to think about is the type of the coupling. How are the two components communicating to each other? How many parameters are being sent and or received? Are we just speaking of a simple string, or are we speaking of a very complex data structure and even many parameters, right? Well, the more parameters and the more complex parameters we're sending, obviously the more tighter the coupling gets. And this we have to take into account. So, but obviously here we have limits because, well, we are not just coding for fun. We're trying to solve a problem of the business. But still, there we usually can discuss and we can see, is this parameter really needed or can we make it simpler, right? But even more, there are more factors because it's also about performance, or another factor might be the readability of the code. So it's not like that it's always that you have to design something in exactly that way. Because the cool thing about software is it is soft. We can change our minds, right? We can later on change the architecture. So the solution might be okay now, but it might not be okay later on. Well, we can refactor the code. That is very important. And that is something that I see many teams don't do. They fear to touch the code. And this we should not do. To achieve a clean architecture, we have to continuously touch the code. I will tell you more about this in the next slides later on. Okay, and the last factor when it comes to the strengths of the coupling is the timing of the coupling. Because we have to differentiate. Do we have two components that are coupled at runtime or at compile time? Well, the more later we couple the two components, the better, obviously. This gives us a lot of flexibility. But again, this flexibility comes at a price. If we're using something like dependency inversion, right, this allows us to couple the two components, for example, at on production at runtime. Great. But, well, what if there is a problem in the coupling of the two components? In the worst case, we would see this problem only on production, and this might be a severe bug, right? So again, are we speaking of two large modules? For example, back to the image that I showed you later on of our hexagonal architecture, there, this might really be helpful, but we would not always use dependency inversion, right? We have to take into account this comes at a price, and we have to, this is a trade-off. Okay, so now this is all I want to tell you about coupling for now. Big topic, but yeah. So now I want to also talk about cohesion. Out of the two, coupling and cohesion, I think cohesion is actually the more important one. Cohesion, I usually say, is the cornerstone towards achieving a clean architecture. So why is that? Well, first of all, what is cohesion? We have to know. And cohesion is about one component. Cohesion is about how closely related are the functionalities, the activities, the responsibilities within one component. Here, I try to visualize that. I hope you can see that. One sec, let me put the pointer. So for example, here we have this blue component, right? And there are subcomponents. These are the functionalities, activities within that component. Now I use the same colors to say the functionalities here, they are really, really close to each other. And here also, right? So just visually, this looks nicely organized, nicely sorted, nicely grouped, right? While on the other hand, in a low cohesive system, this does not look nicely organized. This looks very disorganized, very chaotic, really, like even to the eye, not so nice. And so it's about sorting, it's about organizing, it's about structure, cohesion. And if you think about architecture, is not architecture exactly about that? Architecture is about the structure of the system. And that's why it is so closely related to cohesion. So by getting cohesion right, we will achieve a clean architecture by already, let's say, 80%. Because if we achieve a highly cohesive system, the great thing is that a highly cohesive system usually also tends towards a loosely coupled system. Why is that? Well, let's go back to our colors. Let's go back to the blue color. And let's assume the blue color symbolizes some functionality related to car, right? So one of the blue circles could be the wheel, the next one could be the steering wheel, and another one could be the engine. Well, obviously, these kinds of things, they are related, so they have to talk to each other. They have to depend to each other in some way or the other. Now, if they are spread over the entire system, you will probably understand that this will introduce a lot of tight coupling here, because these components, they have to talk to each other. So this is why a low cohesive system also tends usually to a tightly coupled system. And this is by getting cohesion right, you will by a large factor also get coupling right. But I'm only saying by a large factor because coupling is much more complex. I talked about the strengths of the coupling. So you can achieve a high cohesive system and you can still further improve the coupling, and you have to, right? But still, if you have to make a decision, I would always start with focusing on cohesion first. Okay. So now, cohesion is very similar to coupling in the way that, again, it's not just a binary attribute. It is a sliding scale. There is many, many levels in between. And this, again, makes it so hard to talk and to understand cohesion and to see how we can get this properly clean. So let's also here dig a bit deeper. Okay, so when we talk about cohesion, obviously we have to always look at the entire system. So it's not enough to just get one component highly cohesive, right? Because this component will be used within the entire system. But this is a bit hard to visualize, so here I just focused on one component, and I gave it the name general utils. Now, you might directly think of general utils as a class, and that is okay, but it not necessarily has to be a class. It could also be a module, because cohesion applies to the entire system that we have, right? We have to get our system highly cohesive on all the levels of our architecture. So keep that in mind. So if it helps you, it's okay to think of general utils as a class. Just keep in mind, it could be many other things also. It's a very general concept here. Okay, and the name, general utils, it could give you a hint already. General utils. We will talk about the name later on much more. So let's see, what do we have here? We have three methods: create customer, validate car, and write report. Actually, we don't have any cohesion here. This is just, accidentally put together. So this is what we try to avoid under all circumstances, obviously, right? So let's improve this a bit. Now, we're focusing on one entity. We're focusing on customer. That really helps us a lot already. So this is why this now, even if you see here the level on the right bottom, is already much more cohesive. Also, we're here focusing a bit more on the business. We're selling to a customer, we're invoicing to a customer, and we're helping to a customer. Now, this is like really related to one customer. So it seems like this is related to one activity. But this, again, depends. It depends on the level of abstraction that we're looking at. We can go one level further. We could further split this up, and we could have three distinct components: customer sales, customer accounting, customer service. Now, as you see, this is much more cohesive again. So now, does this mean we should always go for this? No, actually not, because again, there is no free food. There's always a trade-off to make. Because now we have replaced one component and we have introduced three components instead. And obviously, the more components, the more complex our entire system gets. So you have to always take into account the simplicity. If you write something like a customer service, ask yourself, is this simple? Is this understandable? Is this, most important, is this testable? Right? So, and if it is, then this might be perfectly okay to have just a simple customer service. Well, later on, over time, because time is an important factor, this might grow and get too complex. So you can change your mind and you can later on refactor the code and split this up into three distinct components, right? So a clean architecture is always related also to time. You can't think you design your clean architecture once and it will be happy, perfect forever. That's not the case. You always have to every day check your decisions and see if they still apply or not, right? And again, as I said before, this is the cool thing also about software. It's soft. We can change our decisions. Okay. So I'm almost about to close up talking about cohesion. Now, I want to make you aware Well, we said cohesion is about sorting, organizing, or grouping, right? But I never said, well, grouping, sorting by what? What's the criteria? And as for criteria, you could sort by anything you like, for example, time. But again, to keep this short, I think there are two main directions that I usually see happening in code. And here it depends what kind of approach have we chosen. Because if we have chosen, luckily, our hexagonal architecture, we don't even have to make this decision, because we will have separated our two modules by technical reasons and by business reasons. We will have the domain separated, right? But usually it's not so easy, because we might be in a legacy system and we might have a system that uses model view controller. And in this case, you might have to make a decision: should I group my units by logical reasons or by business reasons? And this, interestingly enough, I see this question really often, for example, on Stack Overflow. People would ask, if we're looking at a package, for example, should I group my packages by layers or by feature? Well, I found the answer to this question in a book from 1974. So this should also tell you cohesion, coupling, modularity. This is a super, super old topic. They were, from my knowledge, first discussing modularity in the concept of programming 60 years ago, right? So this is really not a new concept. And the ideas here that I present are also not new at all, but they are more important than ever. So I'm not giving you here the magic trick. This is super old stuff, but still, it seems like many, many people don't know how they can achieve that. So we have to talk about it still. So to answer this question now for you, once and for all, what should I do? Package by feature or package by layer? Well, obviously we're solving a problem for a business, right? So our software is a model of what the business, of what the reality looks like. And so there is a mapping in between these two worlds, right? And the better this mapping is done, we want to achieve that if there is one change in the business, that this one change reflects to only one change in our code. And the way we can achieve that, obviously, is to keep these models very closely connected. And this is, we have to choose for business cohesion, right? So we have to group, for example, packages by features. Because if you do the opposite and you have one package and you have there all the view models in there and all the controllers in a different package, this will not be helpful if your boss comes and tells you about this new feature. You want to look at this whole thing holistically. And this is why you should really choose business cohesion. And this is why you should group your code in packages based by feature for business reasons. This will really help you to achieve a clean architecture. Okay, so, and now, to close up talking about cohesion, here is the key point. This is really, to me, the key, the very important thing about cohesion. Getting cohesion right is super, super hard. Why is that? Well, as I said, we should strive for cohesion based on business reasons, right? And to do so, we obviously we need a lot of business knowledge of the domain that we're working in. And well, most businesses are super old. They might exist for hundreds of years, right? And there might be thousands of people working there. And if you are the new girl or guy working in the team, joining the team, well, obviously you have to acquire a lot of knowledge. And unfortunately, things are never easy, right? This knowledge will not be in the big book that will just be lying on your desk and that you read and you know everything. This knowledge will be spread over several sources. And to make this more difficult, this knowledge will be spread over several people. And this knowledge for each person in the company, that is their secret value, right? That is their sacred value, right? So why, if you are the new person in the team, why would they want to share this knowledge with you, right? So this is, again, a very social topic, and social topics are hard, right? You have to approach the person. You have to make the person open up to you. You have to make the person be willing to share this sacred knowledge with you. And even harder, usually you will have to talk to several people, and they might even be disagreeing to each other. And you have to talk about all this in your team. And again, there might be disagreements. And you will never achieve a common understanding if you're not able to like have a team and be able to solve these social problems also. So when these social problems arise, really it gets difficult. And this is why getting high cohesion right is also so difficult. But to make this even more difficult, we're speaking of a moving target, because here again is the factor of time. Let's just assume you are the lucky person that gets the highly perfect cohesion right today. Well, assuming the business is successful, well, the world is changing. And because the world is changing, your business has to change as well. And it does. And when the business changes, your software has to change as well. So what was highly cohesive today will not be highly cohesive tomorrow. So you have to continuously make changes. And you have to continuously talk to people. You have to continuously discuss that, understand that. That's what makes it so difficult, right? Because we want simple solutions, right? We want to have this quickly, but this is not working. This is not a simple problem, and there is no simple solution to this. Okay, so now that I talked about coupling and cohesion, let me also talk about some other building blocks. They are also very important to achieve a clean architecture. Okay, what do we have here? So first of all, I want to talk about encapsulation. Okay, what is encapsulation? Well, that is actually a very interesting question, because I think if you talk to, let's say, 10 developers, I would assume you get 12 different answers of what encapsulation is. So let me give you my definition of what encapsulation is. Encapsulation is about abstraction. Encapsulation is about hiding details, right? Encapsulation also documents our system, because if you, for example, on a class level apply encapsulation by applying, for example, by making a method private, you document, I don't want this method to be used outside, right? But it's more, it also technically enforces of how the system should be used. And that's really a great help, because if you have two modules, remember that what I said initially, you can now technically enforce how the modules should communicate to each other. And that really helps us humans, because a clean architecture, that is always about humans. A computer doesn't need encapsulation, right? Computers don't have a problem with complexity. We humans do have a problem with complexity. And so this helps us to better understand the system and to not be able to have one module leaking functionality into another module. Okay. So this is how encapsulation greatly helps us. And one thing that when I started many years ago learning about Java, I read in a book, encapsulation was about getters and setters, right? Well, this really took me many years to think about, why do getters and setters encapsulation? Well, actually, I had to find out this is totally wrong. They violate encapsulation, right? And so I hope you agree. Some might disagree, right? So let me explain this quickly, but this is a big topic. So again, here I've put the bit.ly link where you can read more about why I think getters and setters are really evil. But in short, well, we have, for example, a class, and it has attributes, and we made them private because we said we don't want that you access these attributes outside, right? Because we want that you think in functionality. We want to build an object-oriented system, right? And this is why we want to provide functionality and we want to hide data. But now if you provide getters and setters that will directly access these fields again, well, you're countering your whole idea of hiding these fields, right? And this is why you should really avoid getters and setters. If you use getters and setters heavily, you will achieve what Fowler calls an anemic domain architecture, right? So this is really evil, and this is really the opposite of a clean architecture. So we really have to be careful with getters and setters. Okay, and finally, talking about encapsulation, I want to talk also about package and private. Use package and private more often. This is really great. Package and private is there when we don't define any visibility modifier. And that is a bit of a problem, right? Because when we do so, then the next developer will think, he or she will think, well, there was just a visibility modifier missing, and then they will add public or private in front to fix your problem, right? When they actually destroy it. So this is why when you use package in private, please add a comment where you state why you did so. What was your reason that you use package in private, and so that the next person does not fix your problem and that it stays package in private. But I'm still owing you the answer, kind of like, why would you actually want to use package in private, right? So let me give you one quick stupid example. Let's assume we have a class BMW, right? I'm from the city of Munich, so here we build BMWs, so I love BMWs, right? So I have a BMW, and let's assume, we have some method that would allow us to run an inspection on my BMW. Well, public methods are accessible from everyone in the whole world, right? So if I make the inspection method public, now everyone in the whole world would be able to access my inspection method and to run an inspection on my BMW. That might not be such a great idea, right? And this is why such a method would probably better be packaged private. And if my BMW class now is in a packaged BMW, for example, not only a BMW engineer would be able to run an inspection on my car, and I could probably sleep much better. Okay, so let's go on. So now I want to talk about naming. Naming, again, is super, super important to achieve a clean architecture, but it's also not very easy, as we'll see. Okay, why is that? Well, I think I gave you a few hints earlier when I talked about cohesion, right? We had this general utils component. What is general utils? Well, general something, right? Utils something something. So general utils is really something. And that's the point, right? If you have a name that is not very specific, it's really hard to understand what it does. You might have started that general utils component with the best intentions because you said, that's just a quick fix, just a few lines. But your code will live and your code will be read by many, many developers further on over the months and over the years. Whenever the next developer reads general utils and whenever he or she has to find a place where this great new functionality has to live, well, general util seems to fit, right? And this is why such badly named components will usually grow and grow over time and will usually grow into very low cohesive components. If, however, you have a component with a very specific name, for example, account number, well, what does account number do, right? It's probably about an account number, as the name implies. If you have code related to a car, would you put it into a component account number? Probably not, right? But general utils, yeah, hooray, let's put the car code in there, right? So you see, clean names really drive high cohesion. They really help, right? Because the clean name is the first thing that the developer reads, right? Without even looking at the code, this will drive your imagination what this component is about or should be about, right? So this is, again, a way of communication within the team. And because clean names are so important, you should also be very careful with the service pattern. I mean, services really have their right to be there, right? For example, a car service, right? Because they orchestrate of how our system should work. But unfortunately, the service classes are usually also, in a typical system, the classes that are the largest, the classes that unfortunately do the most, right? And the service classes are usually also the uncleanest, the ones with the lowest cohesion. Because again, a car service, the name, just think about the name. What does a car service do? Well, it could create a car, right? It could destroy a car, it could rent a car, buy a car, paint a car, I don't know, repair a car, whatsoever, right? A car service could do anything with a car that is not so specific yet, right? And that might be okay as long as you are aware and as long as you keep this small and simple, it might be okay. But you have to be really careful that it doesn't grow too much, because otherwise your system will be really unclean and be this anemic domain model. Okay, so And clean names are difficult to get right? Because first of all, they are related to the domain. This again relates to domain-driven design, right? In domain-driven design, we speak of the ubiquitous language. I don't really like this word, ubiquitous language. It's a bit awkward, but it's really important because we have to get perfect names that everyone in the team understands, that even the business guys and girls understand, right? Because this is our language that we share, and will drive our entire understanding in the entire team. And this is also why clean names are teamwork. To give you one stupid quick example, I once discussed a simple variable name with a colleague for, let's say, 2 hours, right? And many would disagree, like, why would you discuss a simple attribute for 2 hours? Well, I do this for a reason. I think this is really justified, because if something like such a simple name is unclear, there's usually a reason, right? Because a simple thing should be clear. And if it's not, there is a reason, right? I might not have perfectly understood what the business wants from me. I might not perfectly have understood how the business is working or should be working, right? My colleague might also not have understood it perfectly. And either we're both wrong or some of us is wrong. So we have to discuss that. We might even talk to the business people to get this understanding. If we're not getting this understanding right, the names, before I said, the methods, the small things are the ones that matter. Well, names matter even more because everything in our system has a name. A method has a name, a class has a name, a module has a name, everything has a name, right? So getting these wrong, this is really like you will get the entire foundation of your system wrong. And this is really very, very dangerous. So we have to get this really right. And again, this is a moving target. We will not initially get this right. And we have a moving target. So we have to continuously refactor our system and rename our names whenever we get new insights, right? Okay. So now I want to talk about the last building block that I think is very important to achieve a clean architecture. And this is size. Size really matters, pun intended. Well, because everything that I told you so far, I talked about encapsulation, I talked about cohesion, I talked about coupling, right? And I talked about naming, and I very often said this is difficult, this is hard to get right. Well, size here is a different factor, is a bit more pragmatic, right? Because size, and obviously I'm talking about small size, is about simplicity. Well, the smaller something is, the more simpler it is. And the simpler, simplicity is the opposite of complexity, right? Tackling complexity is really difficult. But if we just start with something simple, we get simplicity kind of for free, right? It's not easy to have something simple, but as soon as we're able to, we get this for free. So this is why we should really try to get everything simple and small. Simplicity really helps towards a clean architecture. And to achieve this, I would recommend you, if you look here at our hierarchy, right? We have modules, packages, classes, and so on. I would, within your team, define an upper limit for each of these layers. I would define an upper limit for a method, for a class, for a package, and a module. When I would give you my numbers, then usually people would fight me and say, I disagree, right? This can really get a heated discussion. So I will not give you my numbers here. Because it also doesn't matter what I think. It matters what you and your team think, right? So what matters the most is that you and your team define an upper limit for each of these layers. Because as soon as you have defined such an upper limit, for example, for a method, now you have a goal. You have a goal that you're trying to achieve, and that really helps. But it's a goal. It should not be a weapon. Very often I see that rules are used like weapons, and that's also very dangerous. You should always stay pragmatic, and you should always stay simple, and you should never lose the focus on your biggest goal, right? Our goal is not to achieve small methods. Our first and foremost important goal is to achieve a clean architecture, and even more important, to make the client happy, right? So we should never lose that from our focus. And if you have a method and that is too large by the definition of your upper limit, it doesn't mean that you have to always apply to this rule. As long as the method is clean, simple, and testable, everyone in the team agrees on that, you're fine to violate the rule, right? It should just be a very quick indicator could there something be wrong? Okay, and this is how I would use size to achieve a clean architecture. Okay, so now to sum up my talk, let me cite David Parnas. He made this statement, and I really like it. And I really think this tells us about how we can achieve a clean architecture. So let me read this out for you. I would advise students to pay more attention to the fundamental ideas rather than the latest technology. The technology will be out of date before they graduate. Fundamental ideas never get out of date. And I think that's really the thing here, because, we have always, there's new technology like Spring 5 and whatsoever, right? Well, obviously, new technology is great and really helpful, but to achieve a clean architecture, we don't necessarily need all these. We need very simple, small things like the ones that I showed you in this talk. And we have to focus on them, and we have to get them right. Obviously, this is not easy and needs a lot of work, a lot of passion, a lot of love for what you're doing, right? And this cannot be achieved overnight. You have to every day work on that continuously. It's like, when we're doing fitness and we're shaping our bodies. If you're just going once to the gym, this won't do much. You will be fat again very soon. We have to continuously work with passion towards a clean architecture. But the great thing is, while there are always new technologies and they are helpful, only if we want to achieve a clean architecture, we will be fine with just focusing on these very old, simple principles that were invented even over 60 years ago. Okay, so that sums up my talk. Now, if you want to download the slides here, you can find the bit.ly link where you can download the slides. Okay, so I will, later on, I can also post this in the chat where you can also ask me many questions. So I will now go on. Okay, so that's it. Thanks. Thanks for listening. And Robert, thanks for having me here. Great honor. I mean, Virtual Java User Group, that's probably the largest Java community in the world, I guess. So yeah, wow. Okay.
Yeah, I mean, we don't know about that. If you're the largest one, maybe we are. But yeah, I mean, it was our definitely pleasure to have you with us here. That was a great presentation, so thank you so much for that. Hey, Dublin Jug, are you still with us? Do you want to post any question? Yeah, they're waving. Do you want to send any questions to Mark?
Waking up.
Yeah, they're waking up. Do you want to send any questions to Marcus?
Hi, Marcus.
Hey.
Well, thank you very much for a great presentation. Did everybody here enjoy the presentation?
Yay.
Do you know something? This is the first time that we've held a VJug here. So you're the first, Marcus. Thank you. And I was very surprised actually, because obviously 6 o'clock in European time is only 5 o'clock here. Oh, could you hear me there?
Yes.
Yeah. So I was quite surprised that we had 20 odd people showed up. So I'm just wondering if they actually got jobs or they're unemployed. I'm not sure. Our recruiter, Jerry, who sponsors the group, is going to go around and hand his card out later.
Okay. Good luck
Anyway,
with that.
there we go. But one thing we'd love to do, actually, before you do go, Marcus, is to get your image on the screen and have everybody stand around it and have you part of our group photo.
Oh.
But maybe we'll do some questions. Maybe we could do some questions first.
Yeah, I mean, let's do that. Let's do the picture. Let's do it later. Unless you guys don't have any questions, we can do it now.
Does anybody have questions? Come on.
We do have. So I'll pick something. We do have a question from Slack. And let me go. So this is coming from Sam. So this is about. I'm gonna mute the Dublin Jug because I can actually hear me as well. Okay. Yeah. So Sam, this was about the discussion about the getters and setters being evil. So his comment or his question about it is: what if we want the value of a variable in a class to be visible outside a different access level for setting the value? Maybe set the value during construction only. Then how does private access specifier on variable decoration and public getter for that variable contradicts the propose?
Wait, I'm also trying to read it, but
Yeah,
is it in general or is it on random?
that's on live session.
Oh, so I guess I'm wrong here.
Yeah,
Okay.
just join the live session.
Okay, so I'm in the wrong chat, I guess. So again, can you? That was a lot. Can you
Yeah,
slowly?
yeah, no worries. So what if I want the value of a variable in a class to be visible outside, but different access level for setting the value?
So he wants to have a variable visible outside the class. Is that what he's saying?
Then how does private access specifier on the variable declaration and a public getter for that variable contradicts a propose?
I'm still not really getting it. So he has a variable and he wants to like have it visible outside, right?
Yeah.
So there I would already disagree because that's what we usually don't want, because that's the point. You know, we that's data and we want to hide the data. We want to think in functionality, and we would not make this. We would want this private.
Yeah, and then basically he goes and says a different access level for setting the value.
Well, that's again, you know, setting the value is again always about getters and setters. That's totally the opposite of what I would do. I would always like, you know, we're offering kind of a service. Our entity should offer a service to the client, and if we just say set something data, this is not a service. We should, you know, we need an abstraction. We need to like hide the data, and we need to be on a higher level of abstraction. And so we should not do this. Sometimes there are exceptions, obviously. So where I would think this is acceptable, for example, if a framework, for example, forces us to do that, well, or if we have a simple DTO in some case, well, but then I hear some people giving me advice, and I think this is not so bad. If we have a simple, stupid DTO, well, then we also don't need getters and setters. We could just make the fields directly public and communicate. This is a not object-oriented class. This is just a data-driven class. And so, again, I would not have getters and setters. Again, I said, you know, this is a big topic, and if he doesn't fully understand the details, maybe it's better that he reads the article, the link that I gave, and we will share the slides. And after he has read the article, if you still have some questions, please just send me a message on Twitter, direct message. You can talk to me, and we'll see if there's still something unclear or not.
Okay. Do we still have some? You still have some time for more questions, or?
Sure. Go ahead. They're coming.
Yeah, Sam is typing here about that, so if you can join the live session channel.
Where is that channel?
Yeah, so let me see if I can actually invite you to the channel myself. But anyway, so I'll
session here. Ah.
Yeah.
Okay.
So another question coming from Frank. There you go. So if you take over some project and it contains classes with a huge amount of methods, what strategy will you suggest to reduce the number of methods?
Okay, so let me repeat what I understood, and we see if that was correct. So he says if we have like a legacy system, legacy also just means an unclean, dirty system, right?
Yeah.
And there is many classes, or at least one class that is just too large and just has too many methods. So it has too many responsibilities, right?
Yeah.
So, well, there are various approaches available. So let me just quickly, have an idea. So, first of all, I mean, touching the code is dangerous, right? So the question is then again, do we have tests or not? In my talk, I did not talk much about testing. I'm sorry, because time is short. So also, by this occasion, I should also say, I'm fully for testing. We need lots of unit tests. And here, the question is, do we have them or not? Because if we have them, we can do more risky stuff and we can go crazy because we have the security net of our unit tests, right? But usually, we're speaking of a legacy system, so someone did not perfectly understand of how we can achieve a clean architecture. So I would just go assume the worst case, we also don't have unit tests, or at least we don't have enough. And now we're trying to fix something without a security net. So this is very difficult. And because it is so difficult and so dangerous, we have to be very, very careful. Well, now I could say, okay, start writing the tests. But I would assume this class is so complex, and you would have joined a team that you're not able to understand the class. And if you're not able to understand the class, you will also not be able from the start to write tests. So we are like in a problem, right? We're trying to improve. We don't have tests. We need tests, but we have to start somewhere, right? So, and in this case, well, I try to start like from both sides. I don't know if I try to write a stupid simple test first, or in another case I would try to slightly touch the code, but sooner or later I would have to touch the code and it would be a bit dangerous. And therefore I would start with changes that will allow me to better understand of what the system, the class does and the methods do, and that are really not risky. And therefore I would start with everything that I can automate, where I can use my IDE. For example, extracting constants. Because very often, we have these magic constants, like magic numbers in there. So I would start with magic extracting all these. And when you do this, you will only be able to give each constant a good name if you have an understanding. So you will already start talking to people. What does the for mean here? So there will be lots of talking. And in the talking, you will get a better understanding. With the understanding, you will be able to start writing simple tests, right? Now, so let's be a bit quicker. This is a big question. I could talk about this for 2 hours. So let's assume we have now a small security net of tests, and we have a better understanding of the whole class, and still we have too many methods. So this was also the question, right? So how can we fix this? And there, well, I would first of all start to group the methods that are seemingly working on the same attributes, or seemingly from the names, from working on the same kind of functionality, because usually it's not sorted, it's all disorganized. So I would just, this doesn't change. I can just move my methods and put them closer. And soon I will see patterns, and I might be able to extract classes. From the large class, I will be able to split it up into smaller classes. And then everything will get more easy. I might also split up. First, I would probably first split up large methods into smaller methods. Again, this is less risky, right? So I will start with the lowest risk until I go to the most risky stuff, because for the most risky stuff, I need a really tight security net of tests, and I need a very deep understanding of how the code works. This, again, is a big question, so I hope this gave you an idea. If not, as I said, send me a direct message on Twitter, or even an email, whatever, or in the Slack chat later on. I hope this answered the question a bit. Okay.
Okay. So now we have a couple of questions in from the Dublin jobs, and so they actually only they write them. So
you can talk to me, guys.
Yeah, I mean, if you prefer, Barry, if you prefer to actually speak the question, that will be cooler.
Oh, can you hear me?
Yeah, we
Yes.
can.
Oh, yeah, lovely. So the first question is there something that was left out and wanted to cover in the presentation?
Yes, there's a lot of stuff that was left out in the presentation and that I wanted to cover. First and foremost, I wanted to talk much more about that social topic. I tried to sneak it in a bit, so I because the thing is, like when I started preparing for the talk, for me personally, with the experience I have, I think the social topics are really the more important ones, because, we are humans and we're working together in teams. And this is not easy, right? We have to come along. And also, when I gave, very interestingly, I gave this talk about 2 weeks ago in Russia. And after the talk, all the people, they told me, they asked me questions like, okay, I'm in a team and I'm trying to touch this and I'm not allowed, right? And whenever you hear, I'm trying to, but I can't because there's another person not allowing me, this is social topics. And then they want to know, how can I solve this? Well, you can only solve this the same way as how you make friends, right? And I think there's even a great books about how you can make friends from, I think, Carnegie or the. I think this topic is really important, and I would talk much more about this topic, but people, when I would propose a talk only talking about these social topics, no one would want to listen to this. People want to hear about architecture, but still architecture is also really closely related to social topics. So to achieve a clean architecture, we have to really get the social topics right of how we are working together in a team. We have to find alliances in a team. We have to make friends. Otherwise, we will not achieve anything. If I'm in a team and no one likes me, no one knows me, no one will listen to what I say and it will achieve nothing. So this is the first step. First, get this right. If you don't get this right, you will achieve nothing. This is one of the things. And let me say a second thing, testing. I would want to talk much more about testing. Unit tests, I love unit tests. I love mocking, big topic, important topic, but out of scope. Okay.
Okay, sorry. Can I go again?
Yep, yeah, go ahead.
Okay, grand. So tools you know tools you know of and
SonarQube?
Sorry, tools that you know of and use to force clean architecture.
SonarQube? Because to me, the one biggest, most important, coolest tool that I really love, that I'm really passionate about, is SonarQube. Now you might disagree with me and say, you know, SonarQube is about clean code and SonarQube is about methods and names and all these rules. But again, that is what I wanted to say in my talk. A clean architecture is about these small things, right? It's not enough to just look at the high level, and it's not enough to just look at this highest level. We have to go down and we have to get the small things right. If we do get them right, we will achieve a clean architecture. And there, SonarQube is a great help. SonarQube in the past had also tools like, I think it's called LCOM4. That is an indicator how you can automatically estimate the level of cohesion that you have. I think they took it out because there was too many discussions in many teams. Because again, the problem is that very often those rules are used as weapons. I don't like this because I always, want to stay pragmatic and simple and open, and I will never lose the main goal we want to achieve. We want to make a client happy, and just because one component is low cohesive, this might not be the end of the world if we can agree on that. And sometimes even the tool is wrong. It's just a tool, right? And SonarQube is not perfect. Very often you also see false friends, So you should not use it as a religion. You should just use it as a tool. But if you do so, I think it's a great tool to achieve a clean architecture.
Okay, I think we can keep going and speak a lot over these topics for the next couple of hours, but we really need to wrap up. So I'll give like one more question for the Dublin Jug, and then we'll wrap up and we'll go.
I will be a bit more in the chat later on, so if anyone wants to, I will try to answer as many questions also in the chat later on, right?
Yeah, I mean, there is a lot of conversation going on Slack, so I think that you, Marcus, should go over there and speak.
Yeah, so maybe I can spend half an hour or so in the chat later on also.
Yeah, thank you very much.
Yeah.
Go ahead, Dublin Jug.
So our last question has actually been texted in from one of our members who's working in a company called VSware. And he's sat in his office with his group, and they're watching your presentation. So the question is, could you give Marcus a worked example of how you would get rid of getters and setters from ordinary Java classes? And also, they're not clear about why accessors are always evil.
So actually, there's two questions, right?
I know.
Okay, sneaking in two questions. So let me see. I'll start with the last one, and I hope I will still remember the first one. So the last one was, why are getters and setters always evil? Well, always, first of all, obviously is always wrong, because there's always an exception to any rule. And I already gave one exception where I said, if there is a tool, a framework, I now hear myself twice. Can you mute again?
Yeah, muted them. Yeah, go.
Thanks. Okay, so obviously there's always an exception, right? I just, I'm very passionate about this topic, and so I say I want to make a strong phrase by saying getters and setters are always evil. So that is really coming over how evil and how much I dislike them. But still, this is not entirely correct. There is always some exceptions. For example, if there is a framework, the framework might help us a lot. So we make the decision we want to use this framework, and for this. Again, everything has trade-offs. So the trade-off might be that this framework unfortunately forces us to use getters and setters. In this case, I would tolerate that. But in the average case, I would not tolerate that, because this is really my experience. It drives us thinking in data. It drives us towards an dynamic model, and this is the opposite of object orientation also. Object orientation is always about modeling. We have a problem in the real world. We have our software that is a model of that. And, do you have getters and setters in the real world? Probably not, right? You have drive car, stop car, brake car. You don't have set speed, get speed, and you can't talk like this to business people also. They will not understand you. So there's many reasons why I would say they are evil. And again, for more details, the article, I spent lots of time, I think this is like 10 pages long, to give you many more reasons why getters and setters are evil. Okay, so that was the one question, right? And the other one was? Can you repeat that maybe?
How you will get rid of getters and setters from ordinary Java classes.
I don't see really the question, because, well, you refactor the code. You can only do so if you have a deep understanding, because first of all, you have, for example, a class house, and there you might have set the house, I don't know, room number or so. So to change that, you need a deep understanding what is actually needed here. What does the client need from an abstract point of view? And if you don't have that, you will not be able to refactor that. There it will be obviously very difficult. And that might be where the person asking this question might be. But if you have really a deep understanding of the system, and you can achieve that by discussing that in the team and with the business. And when I say team, I always include everyone, right? Team does not mean developers. Team means everyone, and specifically the business people. And if you have that understanding, from my experience, it should not be difficult to refactor the code and to make it more thinking in functionality and less in data. Yeah. I know this question, my answer might not be so good. He might not be happy with my question because it's not so easy, because I don't know. I would need much more information of what specific case he has there. So I hope this answers it. If not, I can later on in the chat go more in detail.
Well, he's probably listening to us, so what I'll advise is to join the Slack channel, or you can keep up the conversation over there.
Yeah.
Hey, Barry, I didn't forget, so I was going to talk about that now. So thank you so much for Marcus to being here with us. Thank you so much for Doubling Jug to join us live. And just for the final thing we're going to do here today, something that we haven't done before, we're going to take like a live picture to Doubling Jug. So please, Doubling Jug, come over here. Well, not here literally, but over there.
Should I stand or sit?
And let's take a picture with you guys. You guys might want to mute yourselves if you want to like send any comments. Okay.
Sure.
Just posing together. So.
No, wait. I'll also stand.
Yeah. Oh, maybe you want to have that that banner on your wall visible as well. I'm not sure.
That's okay.
Okay.
No.
Okay, Double Jug, are you guys ready? I only see like a person over there that actually blocking the screen. But let me just change. Okay, now Marcus is like, okay, there you go. I'm actually gonna take like a few screenshots as well. Okay, are you done, Double Jug?
Still standing, sure. So I guess not.
I'm not sure if they're listening to me now. I hope hopefully they are.
Hooray!
Yay! Thank you so much, Double Jug, for joining us, and the rest of the VJug audience. So stay tuned with us for the next session. We're going to announce it very soon. Once again, thank you so much for Marcus for bringing us this awesome session to our community. So thank you so much for your time and your effort.
Yeah, thanks for having me again.
Yeah, it was our pleasure. So see you next time. Thank you so much for joining us, guys, and see you in the next session.
See you.
Okay, bye-bye.
Bye.